Okay, so let's go back to our CAD model and let's talk about the next part that we're going to do. And that's one of these lower pivot clamps. And so this part has got a lot going on. It's got a lot of radiuses, radii. I don't know, that word just feels weird to say. And it's, it seems a little complicated, but there's some great things about this part that are going to make it a little easier. One of those things is that it's symmetrical. So when you're looking at your part and you're going to have to draw it, make a drawing of it, think about what face is going to make most sense as a front face. So, I've got this face, I've got this face, I've got this face. Which one of these is best going to represent the most information? And think about your auxiliary views. And when I say that, I realize that you're probably going to go back to the drawing board literally 3 or 4 times for a complicated part. You may start out and you're like, oh man, I really want this to be, I really need a right side over here. Let me start over and make a new front view. And that's not uncommon. So try something, start playing with it. If it's not working well, start over with a different view as your front view, because you really don't get to, the rest of your drawing has to revolve around that front view. We go back to these standard drawing views. So it's something to consider before you actually bring this in for a drawing, reorient it, and make sure that, you've got a front view that makes sense. So let's go to the drawing for that part now. And so if we look at this, we again have some section views. You've got section AA is coming from this section line, of course, looking in this direction. And this again was just a case of being able to show all this dimensional information without having all these lines in your way. That's another thing to point out, is that you have the option usually of turning on tangent lines or turning off tangent lines. Because of all these radii, you could actually look down on this part and not see these lines. In real life, they don't really exist. Those are edges of radii that don't really exist. But it seems like to me that it shows that better. So I would recommend, and again, that's going to be where you work and what their policies are. Tangent lines on or off is not really a hard rule. That's why it's an option in your CAD software. Do what best conveys the information. And if you're looking at that part and you don't see those tangent lines, it might be kind of confusing what you're looking at. To me, I'm used to seeing them, so I leave them turned on. That's how I've always seen them drawn. But that's what's going on here. And those tangent lines, while I think they help to show what that part would look like from that view, they do kind of clutter it up for dimensioning things to it. So I've created a sectional view where I just have this, basically it's an outline, it's a profile of the part. And I can dimension that without so much clutter in the way. So that's what's happened here. That's the whole reason for this sectional view. And what I did is I cut it exactly on the center line. Let's talk about that center line. Anytime you're going to make a center line on a part, it does need to be dashed. And there's, you'll see that in your CAD software. Your center line will come in with long and short dashes. And it needs to be labeled with a CL or something saying that it's a center line. Now, again, whatever company you work for may not require that, but why not? Again, this is just for the purpose of bringing information to the person making the part. And if you're going to put an extra line on a drawing, it's a good idea to label it. And so this says center line. At Tandem Lock, center line means, and I would feel like this is probably industry standard, center line means everything on the right side is the same as everything on the left side. If that center line goes top to bottom, then everything above is the same as everything below. What that means for you as the draftsman is you only have to dimension one side, because they're going to know that whatever tolerancing you applied over here, whatever details you applied over here, automatically apply over there. If you put a center line right through the middle of a hole, then that hole has to lie in the center of the part. And so it locks down a lot of things, and actually can save you from having to do as much detailing. So that center line is where we pulled this section view from, and it allows us to talk about the diameter of the shaft. It allows us to talk about all these other dimensions here. And now notice I kind of broke that rule I talked about earlier about dimensioning everything from one place. And that's just because in this particular case, it made more sense to have those as protrusions from this surface, right? So I didn't dimension this 0.044 off of the bottom of the part. But I did dimension the 1.37 off the bottom of the part. I did, so you really, if it matters to you how thick this thing is, because it has to have a certain strength, and if it's cross section is too thin, it's going to be an issue. Then dimension it independently. Don't dimension it from the bottom of the part. But the whole point there was, whenever possible, whenever it makes sense, try to stick with a single datum point. Another good point here, this reference. So I said reference dimensions are often thought to be, oh, those aren't important dimensions. The reason that becomes sort of a miscommunication or a myth is because they are used this way sometimes. And in this way, the reference dimension doesn't mean reference another document or something. It means that's based off of reference another dimension on this print. And so when I said don't over dimension things and don't dimension things twice, maybe there is a dimension that isn't so important to you, but you do want the operator to be able to check it. You want them to be able to measure it. You want them to be able to know if it's, in the right place. Then you might put reference dimension on there. And what that just means is that I've already kind of said where this thing should be, and I threw an extra dimension in here. If you're going to double dimension something, you need to decide which one really matters to you, which one's tolerance is really important, and which one is just there for for the operator to be able to measure, and label that one as a reference dimension, because that means reference the other dimension. This is just here so you know what it should be, and that's where that whole myth of reference dimensions don't matter comes in, because well, in that situation they're not the most important thing on the print. But anyway, you get the idea. Here's another good example of not throwing 100 dimensions on the print. Every radius in this part that isn't dimensioned otherwise is 100 thousandths. Now, if what I just said were true, then it would say all radii 100 thou, unless noted or something like that. And you could put that in a note. It doesn't even have to be pointing to something. In this case, every radius is 100 thousandths, so that's all it says. Doesn't have to be on the print up here. It doesn't even have to point to anything. It could be a note down here. Oh, look, just like that. So this is redundant, and it's there to show how both ways could be done. But again, you could have that as a thing pointing. You could say 0.1 or R.1 typical 723 paces, whatever it is. There's lots of different ways of saying that. So you just make sure that you get the message across clearly, and that you don't measure, don't point to multiple things when you could just say that they're typical. Let's see. So we have, the bottom view here, which is actually a section view, and it's sectioned from up top here. Notice all these hidden lines. There's nothing dimensioned on this, but if you were trying to dimension things here, you would probably want to remove some of these hidden lines. But since they're not hurting anything, then they're still on there. Get your isometric view. Again, this is a reference dimension just because it has been stated somewhere else. Basically, what that means is all these things would add up to those dimensions. And so saying it over here is sort of redundant. Another thing, always make sure you have your overall dimensions. It's not a good idea to just stack things and let them add up to an overall dimension. It's a better idea to start with an overall dimension. Now, if in the rare case that the overall dimension doesn't matter to you and you're okay with the stacking, that's fine. But in this case, the reason this is a reference dimension is because the overall dimension, in addition to this dimension, already establishes where this should be. I wouldn't want to just have this and not dimension an overall dimension. So generally you're going to want an overall height, an overall width. Like we have the overall thickness here, the overall length here. You got an overall width here. Those are things that, your operator, your manufacturer is going to want to have. Don't make them add a bunch of dimensions together to get an overall dimension.